Hello guys, we want to discuss something very important in analytical geometry. I introduced equation of a straight line in one of my videos. If you check my YouTube videos, you'll see that particular lecture. But I want to discuss the equation of a circle. And the equation of a circle has to do with equation of locus of points about a fixed point. So if we have something like this, I think I'm good enough. Manage my circle. This is what we call a circle. So these are locus of points actually equidistant from this fixed point, which we call the center of the circle. So in analytical geometry, we use a coordinate to represent the center of the circle. So we can actually represent this with HK representing a coordinate of the circle. And the distance from this point to this point is actually what we call the radius of the circle, while this remains the circumference of the circle. So I can pick, these are points, so many points on, if you take a look at it, if I put it in the plane, and this is the y-axis, the x-axis, and this is actually the origin here. So we are taking this place not to be 0 and 0. So if we look at this on the xy plane, we get to, all these are points, like these are arbitrary points, like, so I can pick this and call it xy. So I can call this point xy. So this becomes an arbitrary point, and it becomes the center of the circle. So what do we do with this? You remember in my last video I discussed the distance between 2 points, and whenever we have 2 points, if this is x1 and y1, and we have another point x2 and y2, the distance between these 2 points, these 2 points is the square root of x2 minus x1, and this is y2 minus y1, all squared. So this is the distance between 2 distinct points on a plane. And this is the formula we use. I'm going to apply that formula in deriving the equation of a circle. So I'm going to regard this as my first coordinate and my second coordinate, just as this was my first coordinate and this is my second coordinate. So if I was to call this h and call this k, then call this x and call this y, that's representing them with this is going to give me the distance now, in this case, the distance between these 2 points is r. So r is going to be the square root of x2, we're not using x2 now, we're using x. So it's going to be x minus h all squared plus y minus k all squared. If I square both sides, the root will disappear and I'm going to be having a square here. So this is going to give me r squared equals to x minus h squared plus y minus k all squared. I can leave it this way. This formula can be used to find the equation of a circle with center h and k and radius r. This is radius. So you can use this formula to obtain the equation of a circle, but sometimes it may not really help. So sometimes we can actually expand this. So if I expand this, this is going to give me r squared equals to x squared minus 2xh plus h squared. That is if I expand this, and if I expand this, I'm going to be having y squared minus 2yk plus k squared. I can arrange this equation to give me x squared plus y squared here plus y squared and minus 2xh minus 2yk, and I think I have something left. I have h squared left, I have k squared left, and on this other I have r squared. So I'm going to take this up. So I'm going to take this up. I think I have to use this place. I'm going to manage this place, please. So I'm going to manage this place. Okay, so take note, I'm not going to go below this line. Now this is going to give me x squared plus y squared. So I'm going to give minus 2h a name. I'm going to call it p. So this is going to be px. I'm going to give minus 2k a name. I'm going to call it q plus qy. And all this, put this in here. I'm going to call it r equals to 0. What does that mean? It means that my p is equals to minus 2h, and my q is equals to minus 2k. Or I can say my h is p over 2 and my k is q over 2. So this and this, I can use this and this to obtain h and k, and I can use h and k to obtain any of these. What is next? What is next is r. So my r in this case now, my r is simply, to go up a little, I'm going to draw it in the graph. So I'm going to add my r to be h squared plus k squared minus r squared. So this is my r, and that is my p and q. So the question is now, how do I obtain these values? My r can be written, r squared can be written as r minus h squared minus k squared. So that can be written as my r, and from there I can have r to be the square root of r minus h squared minus k squared. So take note of what I did. I am taking r squared into this for me to have h squared plus k squared, h squared plus k squared minus r squared to represent my r. And I'm making r, taking this over here. Sorry, I need to make some correction. Sorry. My r, I'm going to be having r minus h squared minus k squared to be equals to minus r squared. I'm sorry. So with multiplying both sides by minus, I'm going to be having r squared to be h squared plus k squared minus capital R, so that my r becomes the square root of h squared plus k squared minus r. So this formula in the box here and this formula in the box here can be used when we want to obtain the equation of a circle. Now, what if we were given the equation of a circle and we are told to obtain the center and radius? What if we are given the equation of a circle and we are to obtain the center and the radius? I'm going to solve a typical question and we're going to call it a day.